Testing a software solution. Comparing a solution to its design specifications means comparing the final product to the original outline and expectation that was made between the project developer and the end user. The developer will have different things they will search for when it comes to testing a solution. A developer will be more focused on data types, algorithms, variables, the software design approach, system modeling, and documentation. Whereas a user will more focus on screen design, appropriate messages, appropriate icons, relevant data formats for display, ergonomic issues regarding the flow of the workflow inside the document or inside the program, and relevance of the computer environment and configuration and other social and ethical issues that will make the program easy and comfortable to use. The guidelines for design specifications include ensuring that the specifications are written in measurable outcomes, clarifying and avoiding using any really vague terms or ambiguous statements. Calculations and other nerdy stuff is accompanied by examples. Annotated pictures to help describe the structures that are being used inside the program. All of these make the program more easily understood and therefore makes its evaluation much easier. Generating relevant test data for a complex solution can be difficult, as many operating factors may be outside the program's control, such as unforeseen or unexpected inputs, such as just odd keystrokes. Hardware variations between manufacturers with differing drivers that could cause unforeseen issues with software solutions, and we see that a lot with games. Changes to operating system functionality and compatibility. Changing and updating technologies where newer systems, whilst being backwards compatible, may not necessarily work exactly the way the developer expects. The increasing size of applications has meant that modularization has made it harder to test absolutely everything in a program. Modularization can help each module be tested individually. In small modules, it may be possible to generate data that checks every path in the application. However, as modules become more complex, more submodules are joined, this may not be a viable option. Some ways to reduce the difficulty of creating test data for a complex solution include using testing procedures, such as a statement covering testing involving the execution of every statement in the module. For example, each statement could be executed at least once. Decision condition coverage testing involves full statement coverage, as in the previous method, but also tests each true and false outcome in each decision. Multiple decision condition coverage testing extends the process of decision condition covering testing to all possible combinations within multiple conditions. That is to say, tests every possible combination of conditioning. Exhaustive this one's a difficult one. Exhaustive decision condition testing involves creating sets of test data that examine what happens with all possible combinations of true and false outcomes for every condition. Black box testing only tests the inputs and outputs of a system. The process that achieves these results is ignored. The most common testing procedures for black box testing include boundary analysis, which involves choosing data elements that are representative of either side of a boundary where the effects of processing are different. So I'll say that again. Boundary analysis involves choosing the data elements that are representative of either side of a boundary where the effects of processing differ. Equivalence partitioning involves breaking up the data into input groups that have the same properties. For example, testing data that is legal and illegal. Module testing is a different type of software testing which checks individual subprograms, subroutines, classes, or procedures in a program. Instead of testing whole software programs at once, module testing recommends testing of smaller building blocks of the program. The objective of module testing is not to demonstrate proper functioning of the module, but to demonstrate the presence of an error in the module. Module testing allows for the use of parallelism by giving the opportunity to test many modules simultaneously. Module testing is recommended because the probability of identifying errors or bugs or in smaller chunks of program become higher. Multiple modules can be tested simultaneously and hence supports parallel testing. The complexity of testing can be easily managed. There are typically two ways to test a program. The first is a top-down approach. This approach requires a developer to make and test the main program first. Doing this often creates gaps in the code where modules and subroutines need to be placed. This is where you would use stubs to output expected values so code further on can continue to run. This is then repeated for making modules and then subroutines. As the name suggests, you work from the largest parts, that is to say from the top down to the smaller parts. The second approach is bottom-up testing. As this name suggests, you work in the opposite direction to top down. The approach requires the developer to first test the lower level modules and then work their way up to the bigger, wider system-wide testing. Once completed, there are various testing systems used to ensure compliance with systems and/or user needs and constraints. Function testing requires a program to be tested where users check to see if the program is working as intended. Acceptance testing is used for custom-built software and is carried out to determine if the software is capable of being used in a fully functioning system. Other aims include how human-computer interfaces work with users and detect any errors that may be missed during any previous testing stages. It can also be used to train users. Alpha testing is a type of software development testing performed to identify bugs before the release of a product to real users or to the public. Alpha testing is one form of user acceptance testing. Beta testing is performed by users of the software in a real environment. Beta is also another type of user acceptance testing. There is also system testing, which is a combination of a number of different test sequences that have been designed to fully extend the system, which include, but not limited to, performance testing, which is used to test the quality of the system, the performance of the software. For example, the amount of information it can handle, how well it recovers from errors. There's also recovery testing, which is forcing the system to fail and measuring the ability of the computer recovering itself or a human recovering the system. Security testing, which attempts to breach the security of the system in an effort to steal data or to see if it can be done. This is also called white hat testing. And stress testing, attempting to create situations where the system will crash, for example, repeatedly smashing it with data. System testing is performed when integration testing is completed. System testing is the first testing technique that tests the system as a whole. It evaluates the functioning of the system as per the pre-decided functional requirements. System testing validates the business or the client's requirement and software architecture. A staging server may act as an environment for carrying out testing. System testing may include functioning and non-functioning testing. System testing is mainly black box testing techniques. Black box testing does not require internal knowledge of the code, whereas a white box testing will. Black box testing simply is inputs, crunch, outputs. System testing is used to monitor and to assess behavior of the complete and fully integrated and fully functioning software product based on its pre-decided specifications and functional requirements. Therefore, system testing does not require internal knowledge of a system, such as its coding, programming, designing, or whatever. It is completely based on the user perspective. Key areas of system testing. Some areas of system testing on which testing focuses include performance testing. It makes sure that the software is performing as per the user requirement without depicting any defects or issues. That's better. Security testing protects the product from any security breaches or data thefts to protect the software using organization. Recovery testing ensures that the recovery of the system works as expected. Interface testing. System testing to focus on the interface of the product to ensure all requirements are met accurately. Installability. The focus on this point is to make sure the product is installed and implemented to in the environment without any issues. Usability, very important aspect, testing whether or not the system is being able to be used by a standard user in an optimum fashion. Documentation, the accuracy of the documentation is also required for monitoring in this testing. And there is, of course, load and stress testing, system tests that are made to see if the system will function under a heavy load. System testing is a level of testing that validates the complete and fully integrated software product. The purpose of a system test is to evaluate the end-to-end system specifications. Usually, software is only one element of a larger computer system. Ultimately, the software is interfaced with other software and hardware systems, and therefore system testing is actually a series of tests, of different tests whose sole purpose is to exercise the fully functioning computer-based system. That was a very long presentation. Thank you for listening.